Hello friends, welcome back to another video. In this video we are going to learn about different number systems, and then we are going to deal with interconversion between one number system and other number system. So let's get on to the video. Hello friends, welcome back to another video. In this video we are going to learn about different number systems and the numbers interconversion between different numbers. So why do we need to learn about number systems is the first question which might arise in your mind. So computer being an electronic device, to store the data, it should store the data and process the data, which would be in the form of binary numbers which a computer generally uses. So we being humans weren't able to convert everything into binary system, which is very tedious, which consists of only all zeros and a series of zeros and ones. Like we can't read what is this, like what is the meaning of this, but then the computers were able to manipulate this. So we being unable to read this binary number system, what we did was we created some different number systems called these binary number system, octal number system, decimal number system, and then hexadecimal, or you can shortly call it as an hexadecimal system. So like in any system there is something called as you'll be having a, let's say I have a number which is of m digit number. Let's say I have m digit number. Let us take that it is a like floating point number. What I mean by floating point number is that it, let's say 20.787, 27.31. so it has a decimal point, and then it has an integral part which is towards the left of the decimal point, and then it has a decimal part which is towards the right side of the point. So let's say I have a m digit number. In that m digit number, let's say k digits are for integral part, and let's say n digits for non-integral part. Non-integral means that which is towards the right of the decimal point or the floating point. So this each digit of a given system is associated with something called as a weight. What is meant by a weight? A weight is defined as something which gives it is the base raised to the power of the position value. This would give your weight. So a weight is your base raised to the power of your position value. So what do you mean by a base? A base is a number which like you will be using to represent a given number. Let's say in binary number system we have a base of 2, in octal we have a base of 8. So in decimal, the system which we humans use, we have a base of 10, and in the hexadecimal we have a base of 16. So this base raised to the power of your position value would give your weight. So for calculating a number, what we do is that we multiply the weight with the position value, like face value. Now what is a face value? A face value is something, let's say 23.97 is the number. Let us consider this number. So this 3 is called the face value, and the position from the point is, this position is regarded as 0, which is to the left of point, and this position is regarded as 1. In this way we will be going on increasing 1 2 3 4 so on, and towards, so this 3 is called the face value, 0 is called the position value, and since the base, let's say we are counting this number in binary decimal system. In decimal system the base is 10. So 10, as I said, 10 raised to the power of, like your base raised to the power of your position value. Your position value is 0, 10 raised to the power of 0 into your weight into face value. Summation of all those things would give your number. Like let us see it over here. The summation of your uh, weight into your face value would give your number. So this is the way how you calculate the given number in any base. So again, this base is your position value into like base raised to the power of your position value, base raised to the power of position value, which is again multiplied with your face value, and the summation of all those would give your number. So let's say I'm going to take your 23.97. So and the thing is that after the decimal point, like as I said, for this you are going to use 0 1. Let's say this number is 3123.97, this is 1 2 3. So your position value would be going on increasing from 0 to your value till the last value. Coming to the numbers which are on the right side of the decimal point, you are going to go into the negative side, like this is 0 minus 1 minus 2. Let's say 7973 is your this is your complete number, let's say. So this is minus 1 position, minus 2 position, minus 3, minus 4, minus 5 position. So now I want to calculate this number in decimal system. So to calculate it, as I have said, that you are going to multiply your weight into your face value. So my face value over here is 3, position value is 0. So 10 raised to the power of 0, this is 10 raised to, I'm writing here weights, 10 raised to the power of 3, 10 raised to the power of 2. So this is 10 raised to the power of 0, 10 raised to the power of 1, 10 raised to the power of 2, 10 raised to the power of 3. This is 10 raised to the power of minus 1. This is 10 raised to the power of minus 2, 10 power minus 3, 10 power minus 4, 10 power minus 5. So these are the corresponding weights. For the each corresponding weight, you are going to multiply with its face value. So that is 3 into 10 cube plus 1 into 10 square plus 2 into 10 power 1 plus 3 into 10 power 0 plus your 9 into 10 power minus 1 plus your 7 into 10 power minus 2 plus 9 into 10 power minus 3 plus 7 into 10 power minus 4 plus 3 into 10 power minus 5. If you calculate all this and add it, you are going to finally get 3123.97973. This is the final answer. This is the way how you calculate the given number by having your face values multiplied with your weights. How you get a weight? The position value, like the base is raised to the power of the position value, then you are going to get your weight, and then multiply that weight with your corresponding face value for each digit. You are going to multiply that. 10 raised to the power of 2 into 1, 3 raised to the power of 10 raised to the power of 3 into 3. So each corresponding one you are going to multiply, and then finally you are going to add each one. So after adding that, you are going to get the final number. This is how you get the number of a given system. So now let us talk about the different number systems. So we have basically, as of now, 4 number system. Those are binary, octal, decimal, and then hexadecimal. Binary, octal, decimal, hexadecimal. So the digits which binary system uses are only 0 and 1. And the octal are from 0 to 7, and for decimal they are from 0 to 9. And for the hexadecimal, since we need 16 bits, like 16 digits, we wrote from 0 to 9, those are 10, and then from A to F, these are a collection of 6, and these are a 10. So 6 plus 10, you are going to get a 16. So these are the digits which this corresponding number system uses. And then coming to the base or radix. Base or radix is a thing which is used to represent the system. So for binary number system, we are going to use 2. For decimal system, we are going to use a 10. For hexadecimal, we are going to use a 16. Similarly, for octal, we are going to use an 8. So now the thing which we are going to do is, let's say we are going to see different representations. Let's say I want to represent a number in binary. So I will be restricted only to use two numbers, 0 or 1. So using 0 or 1, I should be able to write a given combination of numbers. Let's say I need to write So I am only allowed to write zeros or ones in the corresponding binary system. You denote the base in the this circular braces or parentheses. This is how you represent a number in your binary system. Let's say I want to represent a number in octal system. Since octal system has numbers from 0 to 7, I am allowed to only use numbers from 0 to 7. In octal I won't be allowed to use the numbers which are above 7. Let's say I want to write a 9. This is not valid in octal number system, so I would be allowed to write 766. This number is a valid octal number. This is how. So you after writing the number at the final ending, you're going to put a parenthesis, and then in that you're going to denote the like the base of the number system. This is how you represent the numbers. Now we are going to learn about interconversion between one number system to other number system. Let us take a number like, let's say 123.456. So let's say I have given that this is your decimal number. So for decimal number, what you need to do, let's say I want to convert it into your binary number system. So to convert it into binary number system, what we do is that we take the integral part and keep on dividing it by 2, and then we write the corresponding remainders of it. So let us do it. Let's say I'm going to take the integral part 123. If I divide that 123 with 2, I'm going to get a 61 with a remainder of 1. And if I divide this with 2, I'm going to get a remainder of 0 over here. If I divide this with 2, I'm going to get a 7. The remainder 1, 2, 3. In the similar way, you are going to get the. So this is how, like, here you are going to get the quotient, here you are going to write the remainder. So now after the completion, from the bottom you should go on doing this till you get a 0. From the bottom you are going to write the numbers to the top. So 0, 11, 11, 0, 11. This is the binary equivalent of your given 123. But then the integral part is this. But then we want to get the equivalent of 123.456. So now for this part, what you need to do is you need to multiply with 2. For integral part you need to divide by 2. For integral part, you, as I said, you need to multiply, divide, and for the decimal part you need to multiply. So dot 456 is my number. For dot 456 I need to multiply it with 2. If I multiply it with 2, let's say what I'm going to get, 0.912. This is what I get after multiplying this. So the number after this is to be considered now. So this is 0.192. If I multiply this with 2, I'm going to get 1.824. So this you need to remember, like mark it. This into 2 you are going to get. Now after this point you need to discard this and then multiply this 2 with only this, the numbers which are after this point. This would again give you 1.648. You should discard this one. This is 1.648 into 2, and then you should keep on doing this until you get a 1.00 or 0.000. This part would become 0 after some time of calculation. Till then you should be keep on multiplying with 2, and then what finally you do is you need to write it from top to bottom. This is the thing. So this number would be 0.456 in decimal would be your 0. That is 0.011011, and then followed by your number. This is the number for 0.456. So combinedly we want a result for 123 and then 0.456. So what we write is, we write this number 0, 1111, 0, 1111, 0, 11.011, This is going to be your final number in your binary. Now what happens is that sometimes after a certain point of multiplication you get repetitions, like after some point of multiplications, if I get again 8 to 4, which is already, which we already got, we can stop it over here. Why? Because it is called a recursive division. In recursive division, after we have a set of values, after this set of values again the same set of values will be repeated. So we stop the multiplication at that point, at recursive multiplication. So till here we write it and then we stop it, or else if we are not getting a repeated values, we'll go until getting a 1.00 or 0.00. This is how you convert the given decimal number into binary number. Now I have a shortcut for you to convert a given number into decimal number into binary number. Let's say the given number is 123, same number. This is applicable for only completely integral part numbers. What you do is you write the given number 123 and then divide it by 2. Don't consider the remainder. 61 divided by 2, 30, 15 divided by 2, 7, 3, divide 3 by 2 is going to give you 1. So again you are going to get a 0. Now what you need to do is that if the number is odd, put a 1 below it. If it is even, put a 0 below it. 0. So you need to go till you get a 0. So this is your binary equivalent of the given decimal number. This is a shortcut to convert the given number. And if you want to verify, you can verify 0, 4 ones, 0, double 1, 0, 4 ones, 0, double 1. This is a shortcut to convert your given decimal number into binary number. This is applicable for only this completely integral part numbers. This is how you convert a given decimal number into binary number. The next topic is that we are going to convert the, let's say, given decimal number into octal number. Let's say I'm going to take the number binary, as I've said that. Let's say this is going to be the number which we are going to take. So this is given in your binary number system. So now I want to convert this into decimal number system. To convert it into a decimal number system, as I have said that what you could do is you could multiply with its corresponding weights, like the face value. The face value is your 1, and then you need to write your positions. Position value is 0, 1, 2, 3, 4, 5, 7, 8. Let us consider only till here 8, and then after the decimal point, -1, -2, -3, -4, -5, 6. Let us consider only till here. So what you need to do is, now since the base is binary, you need to raise the position value. This is 2 power 0, 2 power 1, 2 power 2, 2 cube till 2 power 8. You will increment it, and after this you need to write 2 power -1, -2, 2 power -6. Now what you need to do is you need to multiply the face value, this one, with this corresponding 2 power 8. Similarly, that corresponding face value with your weight, face value, your weight, face value and your weight. For each of them you will be getting different numbers, and then you need to do the summation of all the face values into weight, which would finally give your number. This would give your number in decimal system. This is how you convert from given binary number into your decimal number system. Now the next method is that you are going to convert the given binary number. Let's say this is a given number which is in the binary system. I want to convert this into, let's say, octal. For octal number system, the shortcut which we use is that we know that 2 cube is 8. So we need 3 bits of binary to get 1 bit of octal. This is the thing which is used. 3 bits of binary is equivalent to 1 bits of octal. So I'm going to group 3 bits 3 3. Now if you're left out with a single digit as we got it over here, you fill with additional zeros and make it into a group of 3. So this is going to be 0 0 1 0 1 1 0 1 1 1 1 1 dot 1 1 0 1 0 0, and again we also have a 1, so make it 1 0 0. So 0 1 1 you convert it into decimal. For each group you are going to convert it into decimal, but now coming to the conversion, you should take this only 3 bits. The position is 0 1 2 0 1 2 0 1 2 0 1 2, not 0 1 2. Again you should put a 0. So for these 3 bits only you are going to convert it into binary to decimal, not the whole number. So these are going to the positions, and this is going to be -1 -2 -3, again -1 -2 -3, again -1 -2 -3, a set of 3 3 3 3. This is the thing which you'll be using. So 0 1 1, if you convert it into decimal, you are going to get a 1. 0 1 1 will give you a 3. You can calculate and see. So this is 2 raised to the power of 1, 2 raised to the power of 0, 2 raised to the power of 2. So 2 4 2 4 2 in 2 power 2 is 4, 4 into 0 0, 2 into 1 2 power 1 is 2, 2 into 1 is 2, plus 2 power 0 is 1, so 2 plus 1 is your 3. This is again 0 1 1 3, triple 1 is your 7, point 1 1 0 is your 6, 1 0 0 is 4, 1 0 0 is 4. This is your octal equivalent of the given binary number. If you want to check, you can calculate it and do it. The long term method is that you need to convert this into decimal, and then in the similar way, from then you need to divide by 8 if it is integral part, multiply by 8 it is your floating part, and then you're going to get your octal number. But then instead of going through the long way, the shortcut is that make a group of 3 3 bits and then make that 3 bits into your this octal digit system. Now let us consider, now I want to convert your given number, binary number, let us say this is my binary number, I want to convert this into hexadecimal. Now you can get the point. Like similarly 2 power 4 is 16, so 4 bits in binary are equivalent to 1 bit, like 1 digit in hexadecimal. So now make a group of 4 4 4 4, and we are left out with 2 digits. For 2 digits, add 2 digits and make it a group of 4. In the similar way, 4 4 0 0. So write it separately, 0 0 1 0 0 1 0 0, and then the next one is 0 1 0 0 1 0 1 double 1 double 0 point triple 1 0 double 1 double 0. For each of 4 bits you convert this into your decimal equivalent. So to convert this into decimal equivalent, similarly the positioning now changes. Previously we had a positioning of 0 to 2 in a blocks of 3 3. Here also -1 -2 -3 -1 -2 -3 3 3. But then now what we have is that we are going to convert it as 1 2 3 0 1 2 3, again 0 1 2 3. So we need to go in a blocks of 4 4, 0 1 2 3 0 1 2 3. Now calculate this in decimal. This in decimal is your 2, this in decimal is your 8, this in decimal is your 10, this in decimal is your 12. But then wait, let us complete it off. This in decimal is your 14, this in decimal is your 12. But then in hexadecimal system, after 9 we start counting from A. So A is your 10, B is your 11, C is your 12, D is 13, E is 14, F is 15. So if you see a 12, you should replace it with C. If you see a 15, you should replace it with F. That is the hexadecimal system. So As we saw at 12 over here, we are going to replace it with C. 2, 8, 10 is A, 12 is C, 14 is your E, 12 is your C. This is your hexadecimal equivalent of your given binary number. This is how you convert a given binary number into your hexadecimal system. But then this is a shortcut method. Again, as you wanted to, if you want a long term method, you are going to convert it into decimal, and then decimal to like binary is converted into decimal, and then the decimal is converted into hexadecimal. For hexadecimal, again divide with 16 if it is your integral part, multiply with 16 if it is your floating part. This is how you convert. This is the long method, but then initially we grouped by using this logic. We grouped 4 bits and then made it into your this equivalent. This is a shortcut of conversion of your this binary numbers into hexadecimal. So these are all the conversions which we need, and then I'm going to give you a few homework problems which you can do it in your home. You need to convert 78.625, which is in decimal system, into your binary. So you need to convert it, which you will be doing it, and then you, after getting this number, you convert it into base 16. So convert this number into binary number and then convert it into hexadecimal number. And then the other question which I'm going to be giving you is 73.52, which is in octal. This octal number you are going to convert it into binary and then convert this into your hexadecimal number. These both are the homework problems. 78.625 based on convert to binary, convert to hexadecimal. 73.52 convert to octal, convert to binary, given in octal, convert to binary and convert to base 16. Right, let me write down all the questions at a single place. 78.625, which is in base 10, convert to binary, convert to, from here convert to hexadecimal. 73.52, which is given in octal, I'll give it in octal, convert to binary, convert to decimal. And then the next question is 1011100101, which is in binary. You're going to convert it into base 16 system, base 10 system, that is your decimal system, and then your hexadecimal system. I think that will be enough for this video. These examples might be enough, and you write down the answers, calculate the answers, and comment below in the comment section. I'll check the answers and tell you the answers. That is it for this video. Thanks for watching this video, and then in the next video we are going to learn about storing of different numbers in the computer system. That will be the end of the prerequisites, and then from the next video we are going to start the programming in C. All these videos till now which we learned are the basics. After learning basics, we are going into the actual programming from the video, which is the next video. Thanks for watching this video. Bye. Comment about this video and subscribe to my channel.